The double-slit experiment. What if I told you that reality does not exist until you look at it? It sounds like a crazy conspiracy theory from a science fiction movie. But this is actually the most famous experiment in the history of physics. And it completely blew Albert Einstein's mind. Let me show you how this mystery works. Imagine a solid wall with two thin vertical slits cut into it. Now imagine you have a tiny gun that fires miniature particles like electrons directly at this wall. On the far side of the wall there is a sensitive background screen that records exactly where every single electron lands. What do you expect to see on that back screen over time? Common sense tells us we should see two clean vertical lines. It is just like firing a paintball gun at the slits. Some paint goes through the left opening and some goes through the right opening. This is how the physical universe is supposed to work according to classical science. But when scientists actually performed this experiment in the laboratory, they saw something that shocked the entire scientific world. They did not see two simple lines. Instead they saw an interference pattern. They saw a lot of different lines spread across the screen. This is the exact same pattern you get when waves of water crash into each other. This means electrons are supposed to be solid particles, but they were acting like pure waves. They were traveling through both slits at the exact same time and interfering with themselves. Physicists were completely confused by this behavior. They decided to play a trick on the universe. They placed a tiny measurement detector right next to the slits. They wanted to watch the electrons closely and see which specific slit each electron actually passed through. And this is the exact moment where our understanding of reality breaks down completely. The very millisecond they turned the detector on, the beautiful interference pattern disappeared from the back screen. The electrons suddenly chose only one slit to go through. It immediately stopped acting like a spread-out wave and became a solid piece of matter again. It changed its fundamental behavior just because we looked at it. This means at the deepest quantum level the universe is not solid at all. It is a giant cloud of endless possibilities. Matter only becomes real and fixed when you, the conscious observer, interact with it. Some modern physicists take this idea even further. They ask the classic philosophical question. If a giant tree falls in a lonely forest and absolutely no one is around to hear it, does it actually make a sound? Quantum physics gives us a very radical answer. If there is no observer or detector present, the tree does not just fall silently. It actually both falls and does not fall at the exact same time. Our universe is a game of possibilities waiting for you to watch it. Schrödinger's cat. If quantum physics says that things can exist in multiple states at the same time, why do we not see this in our daily lives? To expose how absurd this quantum reality is, a physicist named Erwin Schrödinger created a famous thought experiment. Imagine a completely sealed box. Inside this box, we place a living cat. Along with the cat, there is a tiny amount of a radioactive substance, a radiation detector, a small hammer, and a vial of deadly poison. The experiment is designed with a terrifying mechanism. There is exactly a 50% chance that the radioactive atom will decay within 1 hour. If the atom decays, the detector will sense it. It will trigger the hammer to drop and smash the vial of poison. As a result, the poison will be released, and the poor cat will die. However, there is also exactly a 50% chance that the atom will not decay at all. If it does not decay, the mechanism will not trigger, and the cat will remain completely safe and alive. According to regular common sense, after 1 hour, the cat inside the box is either completely alive or completely dead. We just do not know which one it is until we open the box. But according to the strange laws of quantum mechanics, before we open that box, the radioactive atom is in a state called superposition. This means it has both decayed and not decayed at the exact same time. And because the life of the cat depends entirely on that atom, the cat is also in a superposition. The cat is legally and physically both alive and dead at the exact same time. It exists in a blurry cloud of two opposite realities. The cat only chooses one definitive reality the exact fraction of a second we open the box and look inside. Our act of looking, the conscious observation, forces the universe to make a final decision. Before that observation, both realities are equally real. Albert Einstein absolutely hated this idea. He famously argued against it by asking if the moon disappears when nobody is looking at it. He believed that objective reality must exist independently of our observations. Yet, decades of modern laboratory experiments show that subatomic particles really do exist in multiple places and states at once. They only snap into a single, solid reality when they interact with a measurement tool or an observer. Schrödinger's cat shows us that the quantum world is not just strange, it challenges the very definition of what is real. So the next time you look at an object, remember that it might just be waiting for your eyes to lock it into existence. Quantum entanglement. If you thought the double-slit experiment and Schrödinger's cat were strange, welcome to the deepest mystery in modern physics. Imagine you have a pair of magical shoes. You place one shoe in a box and leave it in New York. You take the second shoe in another box and travel all the way to Tokyo. When you open the box in Tokyo, you find a left shoe. Instantly, without looking, you know the shoe in New York must be the right shoe. In our everyday world, this is completely normal because the shoes were always destined to be left and right. But in the quantum world, things do not work that way. According to quantum mechanics, until you open that box in Tokyo, both shoes are actually a blurry combination of both left and right at the same time. They do not have a fixed identity. But the exact millisecond you observe the shoe in Tokyo and it snaps into becoming a left shoe, the other shoe in New York instantly becomes a right shoe. This connected relationship is what physicists call quantum entanglement. It happens when two subatomic particles become deeply linked through a special cosmic bond. Once they are entangled, whatever happens to one particle instantly affects the other one. It does not matter if the two entangled particles are sitting right next to each other in a lab, or if they are separated by billions of light-years on opposite sides of the universe. The communication between them is completely instantaneous. It happens faster than the speed of light. Albert Einstein absolutely refused to accept this idea. According to his famous theory of relativity, nothing in the universe can travel faster than light. Therefore, Einstein argued that quantum mechanics must be incomplete. He famously dismissed quantum entanglement by calling it spooky action at a distance. He believed that the particles must have hidden secrets written inside them from the very beginning. However, decades of modern scientific experiments have proven Einstein wrong. The connection is real, and it is truly instantaneous. When one particle spins up, the other instantly spins down, completely defying our traditional understanding of time and space. Today, scientists are using this exact spooky phenomenon to build unhackable quantum internet systems and superpowered quantum computers. It shows that at a fundamental level, everything in our universe might be interconnected in ways we are only beginning to understand. Time dilation and the twin paradox. We usually think of time as a universal constant. A second on Earth must be a second anywhere else in the universe, right? Well, Albert Einstein proved that this everyday assumption is completely wrong. Time is actually flexible, and it can stretch or shrink depending on how fast you move through space. To understand this mind-bending reality, physicists use a famous thought experiment called the twin paradox. Imagine two identical twin brothers. One twin decides to stay at home on Earth. The other twin climbs into a highly advanced spaceship and blasts off into deep space. This spaceship is incredibly fast, traveling at nearly 99% of the speed of light. The astronaut twin travels across the cosmos for what feels like exactly 5 years according to the clock inside his spaceship. After his long journey, he turns the spaceship around and heads back home. When he finally lands on Earth, he steps out of the spaceship and meets his brother. This is where regular common sense breaks down completely. The twin who stayed on Earth has aged by decades and is now an old man with gray hair. Meanwhile, the astronaut twin who traveled through space is still young, having only aged by 5 years. This is not an optical illusion, and it is not a biological trick. Time actually moved slower for the twin in the spaceship. This incredible phenomenon is called time dilation. According to Einstein's theory of relativity, space and time are woven together into a single fabric called spacetime. When you move incredibly fast through space, your movement through time must slow down to compensate. But high speed is not the only thing that can warp time. Incredibly strong gravity can do the exact same thing. If you were to spend just a few hours orbiting near a supermassive black hole, billions of years could pass by on Earth. The universe allows you to literally travel into the future just by moving fast or standing near a heavy cosmic object. Believe it or not, this is not just a theory for science fiction movies. We actually have to account for time dilation every single day. The atomic clocks inside GPS satellites move slightly faster than clocks on Earth because they are high above our planet's gravity. If scientists did not constantly fix this tiny time difference, our phone maps would lose their accuracy within a matter of hours. Time is not a strict master, it is a personal experience. The Fermi Paradox. Look up at the night sky. There are billions of stars in our galaxy alone. And modern science tells us that most of those stars have planets orbiting around them. In fact, scientists estimate that there are billions of Earth-like planets in the universe. Many of these planets are billions of years older than our own world. This means that life had plenty of time to develop, build advanced technology, and travel across space. If even a small fraction of these alien civilizations built spaceships, they could have colonized the entire galaxy by now. So, a famous physicist named Enrico Fermi looked up at the sky and asked a very simple but terrifying question. Where is everybody? This is the core of the Fermi Paradox. It is the glaring contradiction between the high probability of alien life and the complete lack of evidence for it. We have been scanning the cosmos with powerful radio telescopes for decades. We have sent probes into deep space. Yet, we have found absolutely nothing. No signals, no alien structures, and no cosmic visitors. The universe appears to be completely silent. Physicists and astronomers have proposed several theories to solve this eerie mystery. One popular idea is called the Great Filter. This theory suggests that there is a massive evolutionary wall that advanced civilizations cannot cross. Perhaps life is common, but it almost always destroys itself with nuclear war or climate change before it can leave its home planet. Another theory is the zoo hypothesis. This idea suggests that advanced aliens are out there, but they are hiding from us. They might be treating Earth like a protected nature reserve, watching us from a safe distance until we are mature enough to join them. Or perhaps, the truth is much more simple and terrifying. We might be completely alone in the endless dark of the cosmos. Earth might be the only place where the spark of conscious life actually happened. Whatever the answer is, it is mind-boggling. If the universe is full of life, our future could be full of cosmic neighbors. But if the universe is truly empty, then we carry the entire light of consciousness alone in the dark.